Okay, so in today's lesson we have Applied Maths 2010 paper. Okay, we're going to be using this demarcation scheme to help us out on these questions. Okay, so 2010, and this is question 1A. Okay, so we're just going to read the question. A car is traveling at a uniform speed of 14 meters per second when the driver notices a traffic light's 98 meters ahead. Alright, so you're traveling at 14 meters per second, and then in the distance, what you're going to notice is your traffic lights, okay, and your traffic lights stops up around here, and this is your traffic lights, okay. So you have to stop in your 98 meters, okay. So 98 meters going forward and going backwards, okay. Now, find the minimum constant deceleration required to stop the car at the traffic light. Now, the minimum constant deceleration, okay, the minimum means that it's going to travel, the car itself, which is represented by the black dot, it's going to travel all the way along, and it's just, but it's going to reach the traffic lights, but when it gets to the traffic lights, its final velocity is going to be 0. Okay, so what we can do here is we can write down our u vast, okay, which is our sets of information. U being the initial speed being 14, the final velocity being 0, the acceleration, which is the whole point of the question, is what we're looking for. Okay, and the distance, we know is 98, and the time that we don't know. But the whole point of the question is to find out the acceleration. Pick a formula that has all three letters. We need V, U, S, and A. So we're going to use V squared equals U squared plus 2AS. Now the 2FS they use in American schemes. F basically means acceleration, okay? So they use F instead of A for the American schemes, okay? You don't actually have to do this, so please don't worry about always use A if you wish. Okay, so what we're going to have here is we're going to plug it in. So phi squared, phi is 0, so 0 squared, u squared is 14 squared, 2fs is 2, multiplied by f, multiplied by 98. What we're going to do is we're going to multiply these out, so we get 0 equals 196 plus 196f, 96f. Bring over the 196 over to your side, so you're going to get 196f equals 196. F therefore is minus 1 ms to minus 2, minus 1 meters per second, which is exactly what we expect, okay? Next one. Next question we're asked here is if the driver hesitates. Now the driver's going to hesitate by a second before braking, okay? So he's going to hesitate for a second. So let's go back to our diagram, okay? And instead of the 98 meters that happened in the first question, okay, what's going to happen is this. If you imagine the driver, he's traveling for he had 98 meters at the start, okay, and he had 98 meters at the start. He was here, the traffic lights are up here, okay, and this is 98 meters. He delayed in hitting the brakes, okay, so it was 98 meters. So in this extra second that he delays his braking, he's just after traveling 14 meters. Because remember, he travels 14 meters per second. This leaves 84 meters left over. So what we're going to have is the exact same system as last time, except the distance is going to be 84. Okay. Once again, we're looking for the minimum constant deceleration. So he's going to travel 84 meters and hit the lights. Okay. And we don't know the time. So it's going to be the exact same question as last time, except we're going to u is 14, phi, u is 14, u is 14, phi is 0, a equals, a is what we're looking for, a is the target, okay, so we're looking for to find out what a actually is, okay, so we're going to get here. This here just determines that the 14 meters per second, the 14 extra meters travel, okay? So I'm just going to write down u vast, okay? So u vast, once again, u is 14, v is 0, a is the whole point of the question, 84 is the distance. We're going to use phi squared equals u squared plus 2as. Don't mind this 98 minus 14. That just basically tells you that the distance is 84. So S is actually 84, okay? Multiply it in, and what we're going to get is, we're going to get 196, so 0 equals 196 plus 168F. Then we want to get f on its own, so bring the 196 over the other side, and then divide it by 168, and we know that the deceleration therefore has to be minus 7 over 6. And it's what you'd expect. See, in the first answer, he has a bigger distance to decelerate over, so his deceleration only needs to be minus 1. But in this second question, he has less distance to brake in, so his deceleration therefore has to be bigger. Always think about the questions as you're doing them. Am I expecting a bigger answer, or am I expecting a smaller answer? Okay, this one here now is a tricky question. Okay, it involves now remember when you're doing these questions that this is basically 2010 here. Remember when you're doing these questions and they involve straight line going through several posts or gates. This is what's called the interval question. Okay, so we gotta be careful of this. So a particle passes p with speed u, or speed 20 meters per second. So u equals 20. Okay, and moves a straight line to q with uniform acceleration. That's grand. So u equals 20. Okay. A, we don't know. In the last 3 seconds of its motion before reaching Q, it travels 13/20ths of PQ. So in the last 3 seconds of its motion. Now in this last 3 seconds of its motion, let's pick this as a generic point Y. Okay, so this point Y here, and this distance here, last 3 seconds of its motion, okay, it travels 13/20ths of PQ. Okay, so let's call this 13/20ths of PQ. 13 over 20, okay? Now, if that's 13 over 20 PQ, and what we can always call PQ, we can always call the tire distance D if you want, okay? So, because the tire distance can be D, so we call it 13/20ths of D. Therefore, the force from P to Y, therefore, has to be 7/20ths of D. Okay? Now, let's examine. And the first second of its motion after passing P, it travels 25 meters, okay? So we have 25 meters from P to X, okay? So P to X is 25 meters, okay? 25 meters. Now, what we need to do next is we need to write down as much information for each interval as we have, okay? So all the information in each interval. So the first interval is Px, and I'm going to UVAS Px. UVAS Px, and what we have here, we're just going to write down as much information as we have, okay? So u equals 20, v we don't know what it is, okay? So please remember that this here is representing P to X, so we can see here, P, X, Y, and Q. Okay. So what we're looking to do, we're looking to write down as much information as we have. Let's call it acceleration A. S is 25, and we know that it goes to P to X in T in 1 second of its motion, okay? So what we're going to do here is, because we have 3 items of information, this means that Px is a good information set to use, okay? Let's write down the UVAS for Py. So this one here belongs to Px. Next one we're going to do is Py. Okay, now Py, before we even begin, is going to be the UVAS for Py is u is going to be 20, because remember in these questions the goal is to always start it at the same beginning point. That means you get to use u over and over again. So Px, Py, and Pq. That is always the goal of the question, is to use the start to the end point, the start to the end point. In these questions we rarely ever segment out like x, y. It's much slappier that way, so this is the general technique, okay? So v equals, we don't know what v equals, we know that. We haven't got the acceleration yet, so we don't know what a is either. And we know that s is 7/20ths of d, and we know that we don't know what t is, okay? So t, we don't know what t is, okay? So basically Px has the most information, and we're better off to use it. We have u, s, and t. This therefore means we got to use s equals ut plus a half at squared. And when you use ut plus a half at squared, we just plug in our numbers, s being 20, u being 20, t being 1. We don't know what the acceleration is, so the whole point of this question is to get f on its own. So we're going to end up with 25 equals 20 plus a half f. Bring over the 20 over the other side, and we're going to get a half f equals 5. Therefore, f equals 10 meters per second to the minus 2. Remember, it has units. Never leave out your units, okay? So, the acceleration here, I'm going to write this now, and it now equals 10, okay? So we can say that the acceleration here equals 10, and this equals 25. Now, let's go down to py. Now what we know about py is py now has acceleration of 10. Okay? Now, if we reread the question, okay, we need to find the distance from P to Q. We need to find the whole distance. We need to find out what D is in total, okay, the full distance D. In order to do this, we have to find out the times, the total time. We know y to q is t equals 3 seconds. We know p to x is t equals 1 second. We need to do x to y. So let's call x to y t. Okay, so we have no idea what t is. Okay, now we're just going to do a bit of rubbing out here, and we're just going to concentrate on the times at the moment. Okay, so when we rub out this, it'll come a bit clearer. Okay, so what we're going to do, once again, the whole point of these questions is to use the start to finish, okay? So p to x gives us no new information. We know everything there is to know about p to x, okay? We can get the final velocity quite easy if we want, but you know what we want to do is we want to figure out what time this is here. So we need to make sure this is included in the information set. So I suggest we go from p to y, okay? And if you go from p to y, the time is going to be t plus 1. T plus 1 is the time it takes to go from p to y. Now, you could try and use y to q, which is 13 over 20ths of the entire distance. You're not going to do that because you always want to start off at the very beginning. So you're going to go from p to q. So remember, it's going to be t plus 1 plus 3. That gives you t plus 4 seconds to get from p to q. Now we're going to assemble our information set for py and pq respectively, okay? So py can be over here. I'm going to put pq over this side. And we're going to u-vast both systems, okay? So let's see what we know. U is equal to 20 on both of them. A equals 10 on both of them. Now S. For PQ, P to Q is the entire distance. So P to Q is the entire distance D. Okay? P to Y, however, is 7/20ths of D, because it tells you that it's 7/20ths, because it covers 13/20ths from Y to Q, okay? So the next thing you're going to do then is you need to find the time. The time for this one is t plus 1, and the time for this one is t plus 4. Now to decide what you're going to do next, you need to find out the time, but you have two variables, okay? So two variables here. So what we can do is we can get two equations with two variables, and that should mean that we should be able to fix this, okay? So what we're going to do first is we're going to work with py, okay? Look at your list, and it's s equals ut plus a half at squared. Ut plus a half at squared is going to be u. You're going to have t, you have your distance s, and you have your acceleration. Let's work with this. Now remember, PQ for me is going to be D. Okay? So anywhere I see PQ, I'm just going to write down D, just to make it a bit easier. Okay? So what's going to happen here is we're going to write this in 20 into t plus 1 plus 5 into t plus 1 squared. You're going to multiply these out. T plus 1 squared, 20 multiplied by t multiplied by 1. When you add them all together, you're going to know that 7/20ths of your entire distance equals 5t squared plus 30t plus 25. Okay. Next, you're going to use PQ. You're going to use S equals UT plus a half AT squared again, or FT squared. You're going to put in your numbers. U equals 20, done. T equals T plus 4, done. Acceleration equals 5. Now see this acceleration of 5 here. That's basically a half of 10. Remember, a half of 10, half f, or half the acceleration equals 5. Okay? So this is why we have the 5 here. So it's a half f, which is 5t plus 1 squared. This one here is going to be 5t plus 4 squared. And now we know that this 5t squared plus 60t plus 160, this equals the entire distance d. Now, we know that 7/20ths of the distance equals 5t squared plus 30t plus 25. That's basically information set A. Okay? So basically, A should equal 7/20ths of equation B. And this here is equation B. Okay? Because this is 7/20ths of D and this is the entire D. Okay? So therefore, we're going to multiply. We know that A equals 7/20ths of B. This one here is 7/20ths of B, and this one here is going to be equation A. Now what happens here is we just multiply them out, cross multiply. So I'll just do this in the corner, okay? So 7 multiplied by 5, 35t squared. 7 multiplied by 60 plus 420t. I'll do it down here, excuse me. So I'm just gonna do it in this just blue box here, okay? Just to let you know if I can fit it in. Okay, so 7 times 5t squared is 35t squared. 7 times 60, 420t. 7 times 160. 7 multiplied by 160 is 1120. Then on the other side, we got to multiply this by 20, okay? Because the 20 gets, so we're multiplying 7 in on top. The 20 is going to multiply by the A, okay? So basically what we're saying is if you were to cross multiply this, 20A equals 7 times equation B. So that's what we're doing. This is 7 times equation B, and on this side we're going to have 20A, okay? And then what we're going to get here is we're going to get 20A is going to be 100t squared. Plus 600t, 25 times 20, that's going to get you 500, okay, plus 500. Now, all we got to do, if I rub all this out for a minute, okay, just to make it less confusing, what's going to happen here is basically when we move them all over one side, we're going to decide to move everything over to this side here. Okay, so everything comes over one side. When you get that, it's going to end up to 65t squared plus 180t minus 620, exactly what we're expecting, okay? So just going to rub that out. And then all we got to do is just go through the minus b formula. So A, some people can factorize. Some people can factorize this, which is grand. Okay, so what you could do is you could divide by you could divide everything here by 5, and you get 13t squared plus 36t minus 620 equal to 0. I personally went for the minus b formula where a equals 13, b equals 36, c equals minus 620. Okay, then you just go to the minus b formula, plus or minus the square root of b squared minus 4ac all over 2a. And then once you do that, what's going to happen is you're going to get t equals 2. You'll get a minus answer and a plus answer. And remember, time has to be positive, okay? So it's got to be the plus answer. Now, once we know that, what we had to do next was we had to find out the entire distance of PQ. So we know the time is 2, which is perfect. We had to know the full distance PQ, and we have the equation for the full distance of PQ. The full distance of PQ is basically 5t squared plus 60t plus 160. So we could just put it right in there if you wanted. So 5 times 2 squared plus 60 times, oh sorry, not 5 times 2 squared, sorry, 5 times 2 squared plus 60 times 2 plus 160. Add all them together. So what you're going to get is 20 plus 120 plus 160, and that'll get you 300 meters, okay? Alternatively, you could just UVAS your system again, and now you know that basically t plus 4 was your entire time, so t plus 4 is now 6 seconds. S we don't know, A is 10, U is 20, V we don't know, our target is S, so what we could say is that S here, or PQ, equals UT, which is 20 times 6, plus a half AT squared. Remember, a half A, or half 10, is 5. Okay, so 5 times 6 squared, and you get 300 meters. Okay, it's quite handy. Next one is the 2009 paper. Okay, now this one seems okay. A particle is projected vertically upwards. Okay, so the particle here is projected vertically upwards. I'm just going to move my diagram over here a little. So this is 2009. So a particle is projected vertically upwards from the point P at the same instant the second particle is let fall vertically from Q. The particle meets at R, so there's two particles, if you will, a red particle from Q falling downwards and a blue particle from P thrown upwards, and then at this point here the blue and the red particle will meet each other and collide. Okay, they have equal speeds when they meet at R. So they're both moving at exactly the same pace when they meet at R. Prove that PR equals 3QR. So prove that the distance PR is 3 times QR. So just to get a picture of what you might need to do, you're just going to have to UVAS both systems, okay? So we're going to have a system QR, and we're also going to have a system PR. And what we need to do is we need to write down as much information as we can about both sets, okay? So Q, remember Q is let drop, okay? So U equals 0, because at Q it's just allowed drop, okay? So same instance is let fall. Let fall means U equals 0, okay? And if you're projected vertically upwards from a point P, you gotta have a speed to leave. So we're gonna call PR the speed it leaves U, okay? Because it needs to be projected upwards. Then we're gonna go for V. We know that the V's are equal to each other. So that's the good thing about this question. We know that the velocities are equal when they collide, because particles have equal speeds when they meet at R, okay? It's very important. Let's go for A's. For A, for the QR system, is going to be 9.8, or gravity. Okay. So we just call it G actually, okay? And then it's working with it, so G is working with because the particle is falling, okay? But for PR, gravity is working against it because gravity is acting downwards. So A is going to be minus G for this one. Okay. The next thing we have then is we need to know what S is. S is basically the distance QR, because we don't know what it is. And S here is the distance PR. We know that both of them collide after 2 seconds, so T equals 2 and T equals 2. Okay, now using this information set, what we're going to do next is we're going to just go into it. So we're going to use this for QR. Okay, so for QR, what we're going to do is V equals U plus AT. Okay, V equals U plus AT. So the velocity equals 0 plus G times 2. The velocity is 2G, or basically 19.6 meters, okay? Meters per second. Okay. Now that we know the speed of QR, we can also find the distance of QR. So for QR again, what we're going to do is we're going to find S, and S equals UT plus a half AT squared. Now remember, for information set QR, U equals 0, so it's going to be 0 plus a half G times T squared, okay? So it's going to be times 2 squared, and S is going to be 2G. Okay? Now, let's go up to information set PR. Okay, so what we figured out from Q is that basically this here is 2G. Okay, or 19.6, depends if you want to do in decimals or not. Okay, the distance here is going to be 2G as well, or basically 19.6 meters. Okay, now we got to find out what PR is. Okay, so let's use what PR is. Okay, so for PR, we'll use blue pen for PR, information set PR. We're going to use V equals U plus AT. Find out what this is here. So we're going to get so we're going to use V equals U plus AT. We already know V, but we want to find out what U is. Okay, so that's what we can use. We can use this V to find the U for PR. Okay, so we can get is 2G equals U. So that's going to be U plus AT, which is going to be minus 2G. U therefore is going to be equal to 4G, or 39.2 meters per second square meters per second. Okay. Now, next thing we gotta do is find the distance of PR. Okay, so to find the distance of PR, or the length PR, PR equals UT plus a half AT squared. So it's going to be 4G UT. So UT is 2 plus a half AT squared. So that's going to be plus a half times minus G times T squared being 2 squared. Okay. And then what we're going to have here is we're going to have PR equals 8G minus 2G. PR therefore is 6G. And because PR is 6G, or 58.8 meters, we know that QR is 2G. So 6G divided by 2G, we've proved that it's 3 times bigger. PR is 3 times bigger than QR. Okay? So hence, since QR equals 2G, the length of QR equals 2G, the length of PR equals 6G, hence PR equals 3 times QR. And that's what we're asked to prove. Okay? Next question. Now this one here is extremely difficult question in my opinion. So we'll give it a go now. A train accelerates uniformly from rest to speed v meters per second with uniform acceleration f. It then decelerates uniformly to rest with uniform deceleration or retardation of 2f ms minus 2. Find the total distance travelled in d meters. So we're going to draw a speed time graph for the motion, okay? So remember, for speed time graphs, the speed is the y-axis and time is the x-axis, okay? There's two parts of the journey. The first part of the journey is basically where it's accelerating. So accelerating, we should call the this the red triangle. That is going to be acceleration, okay? And the second one here is going to be the we'll call this the blue triangle, which is the deceleration part. Okay. Now we can have we can use U v equals U plus AT. That's okay. Okay. So part one, draw a speed time graph of the motion of the train. Okay, which is perfect. Now, there's something else to note. Okay, v equals U plus AT. Okay, we know that U equals 0 because it starts from rest, and it ends at rest. So U equals 0 here as well. Okay, so remember, there's two ways of doing this. Okay, a really easy way to get the deceleration, we can use U plus AT, and what we could always say is we could U vast the system. Okay, where we can say that U is 0, V is V, A equals, what does A equal? A equals F, if I'm correct. And then we can say S equals we don't know what, and T equals T1. That's for the acceleration. For the deceleration, we could always say that U equals V, because remember, it starts off at V. V equals 0, because it travels down and ends at 0. A equals, now the acceleration here is a retardation of 2f, so it's going to be minus 2f, okay, it's going to be the deceleration, okay. S equals, we don't know, and T equals T2. Now, you could go through your procedure here, and what you could do is you could use V equals U plus AT, as discussed, and what we could end up getting is this. We could end up getting V equals U plus AT, so V equals FT1, okay, and therefore F equals V over T1. Now, a really easy way of doing this is that acceleration equals tan A. So F could have just been tan A. And what we could have got here was F equals tan A. Therefore, F equals, remember, opposite over adjacent, which is phi over T1. Just saves a lot more time. Likewise, we could have done this one here. And we could have said, oh, wait a minute, for this information set, we could have said V plus U equals U plus AT. So we could have said 0 equals U plus AT, which is going to be phi minus 2ft, T2. And then T2 equals phi over, F equals phi over 2T2. Okay? Now, it's very easy to get that, okay? Or we could just use tan B. Tan B is the deceleration as well. Okay, so tan B is the deceleration, which is opposite over adjacent, which is going to be phi over T2. Okay, and the deceleration for this one would have been 2f. So 2f equals phi over T2. Therefore, f would have been phi over 2T2. Okay, so just keep that in mind, alright, for a minute. Just a quick explanation of basically why you can use tan A and tan B quite handily. Okay, so as we see off from the solution, okay, we've drawn our velocity time diagram, label your axis. We take 10 marks home with us for that, okay, so we're very happy about that. Next thing is average speed. The average speed of the train for the whole journey is d over root 3. Find the value of f. Now remember, the average speed equals total distance, or total d, divided by total time. Our whole goal of this question is to find the total distance and the total time, and equate it back to this, and then hopefully find out what f is, okay? So, as discussed before, f, the deceleration, or sorry, this is the acceleration, and the second part is the deceleration. The acceleration is phi over T1. So f equals phi over T1. Therefore, T1 equals phi over f. Remember, we need to find the total time. Hence, getting T1 and T2 on their own is very important. Okay. Next thing, we're going to get T2 on its own. So for the deceleration, 2f equals tan B. Tan B is basically opposite phi over T2. Okay, so phi over T2 is the deceleration. So 2f ends up to be phi over T2. Get T2 on its own. Therefore, T2 says it's phi over 2f. Okay, next step, get the total time. The total time is T1 plus T2. That's going to be phi over V plus phi over 2f. Common denominator of 2f. Let's put a 2 in here and a 2 up there. Add them together and we get 3v over 2f. Next thing, total distance, okay? So what we had to do for the total distance is find out what is the area of the triangle. Now the area of the triangle, okay, we know that the entire bottom is 3v over 2f. The total time is 3v over 2f. And we know that the area, the distance, equals the area of the triangle. Okay, area of this triangle. And we know that the perpendicular height is v. And we know that the base is 3v over 2f. Therefore, the area of this triangle has to be a half v multiplied by 3v over 2f. Okay? And that s is going to be equal to 3v squared all over 4f. Okay, so 3v squared over 4f. Okay? So, as I said, 3v squared over 4f equals the entire distance d, or the entire, so the entire distance, okay, so we can call this d here, okay, that's the entire distance, okay, and this equals 3v squared over 4f. Cross multiply the 4f, and what we can get here is 3v squared equals 4fd. You wouldn't really know to do that just yet, so you could leave it where it was. Now, we're finally, the last section, we're going to equate total distance, average speed equals total distance over total time. Okay? So, the square root, I'll do it over here, pretty much on my own here, probably best to do it this way. D over 3 equals total distance, okay? Now, the total distance is D. The total time was, total time as discussed before, is 3v over 2f. Okay. Then what we're going to get is we're going to work on this to make it one fraction. Okay. So to work on this, we just bring this to the top, and what we get is 2f over 3v. Just turn it upside down. Okay. So d equals 2f over 3v. So root d over 3 equals 2fd all over 3v. Okay, I'm going to square both sides. Square both sides, just to be careful here. And what we're going to get is d over 3 equals 4f squared d all over 9v squared. Okay, but what we know about d is d over 3 equals 4f squared. Okay, so what we need to do here is we need to cross multiply. So what I'm going to get is just move this up, and we're going to get 9. The d's will cancel. Okay, cross multiply the 3 up and the 9 up. So we're going to get is 9v squared equals 12, and that's a d squared, so that still leaves 1d over. Okay, it meant to be a d squared, 4f squared d squared. Okay, so 4fd squared, so when you cancel the d, it just leaves a d left over. So we're going to get is 9v squared 9v squared equals 12fd. So divide both sides by 3, and we're going to get 3v squared equals 4fd. Sorry, 4f squared, because that's squared, so 4f squared d. Now, if we had to compare this to the equation we got earlier, we got 3v squared equals 4fd in purple, okay? So 3v squared equals 4fd. What's basically happening is there's an extra f in here, and this extra f has no influence on the result. Therefore, f must be equal to 1. Or what we can simply do is we can simply divide both equations by each other. So if you imagine we just divide both sides by each other. So 3v squared divided by 3v squared is 1. 4f squared d divided by 4fd is going to be f. F equals 1. F equals 1 ms to the minus 2. As I said, lads, very difficult question, okay?